العلوم، مدير العلوم في في أكاديمية الفضاء في الشارقة. الدكتور إلياس شارك أيضا مع فريق طبعا علمي وتقني في ما نسميه بالقمر الصناعي الإماراتي الشارقة سات 1، كان في سنة أعتقد قبل. نعم. للدكتور خبرة في مجال الأبحاث وخصوصا في مجال الفلك، نشر أكثر من 250 بحث علمي في مجلات علمية مرموقة خلال 30 سنة تقريبا. بالإضافة إلى النشاط البحثي والنشاط العلمي، الدكتور متميز في شيء وهو التعليم والتوعية، التوعية العلمية، وخصوصا لجيل الشباب والناشطين في مجال العلوم والتكنولوجيا. فللدكتور مساهمات كثيرة في هالناحية، وخصوصا له حوالي أكثر من 2000 نشاط علمي في مجالات مختلفة، من إقامة ورش عمل، محاضرات علمية عامة ومحاضرات متخصصة، رصد الظواهر الفلكية في الإمارات، إلقاء محاضرات، مشاركة في البرامج التلفزيونية، مراقبة الظواهر الفلكية، نشر مقالات علمية ومقالات عن الفلك والفضاء في الجرائد والمجلات. الدكتور ساهم في توعية جيل كامل من الشباب خلال مرحلة 30 سنة من أجل العلم والتكنولوجيا وخصوصا في مجال الفلك. فأعتقد مساهمات الدكتور واضحة وخصوصا في الإمارات العربية المتحدة. شكرا جزيلا دكتور إلياس على قبولك للدعوة من مركز الشيخ إبراهيم ومجيك إلى البحرين، وإحنا باسم مركز الشيخ إبراهيم نتقدم بالشكر الجزيل لك وللحضور الكرام. محاضرتنا اليوم محاضرة مهمة جدا. لماذا؟ لأن إحنا الآن نعيش في عصر العلوم والتكنولوجيا، التكنولوجيا في الأرض والتكنولوجيا في الفضاء، استخدامات التكنولوجيا في مجالات كثيرة. الآن الفضاء معرض إلى الطقس الفضائي. الطقس الفضائي يعني ما يأتي من الفضاء من ظواهر، هذه الظواهر تؤثر على الأجهزة في الفضاء. فمن ضمن الأجهزة احنا نعرف أنه الأقمار الصناعية، أقمار الأبحاث، التلسكوبات الفضائية، البراصد الفلكية، المحطات الفضائية، فجميع المنشآت الإلكترونية في الفضاء معرض لطقس فضائي. الآن تعريف الطقس الفضائي الدكتور راح يتكلم أكثر، ولكن من ضمن الطقس الفضائي يمكن ظاهرة نسميها العاصفة أو العواصف الشمسية. العاصفة الشمسية عاصفة قادمة من الشمس، والشمس احنا نعرف عبارة عن مفاعل نووي. تأثير العاصفة على الأجهزة تأثير كبير، فتسبب عطل، تلف، إلغاء الاتصالات، أشياء كثيرة. تصليح الأجهزة في الفضاء عملية أعتقد مستحيلة أو صعبة. فإذا يجب البحث عن وسائل أخرى لتخفيف الأضرار. تخفيف الأضرار يأتي عن بناء نظام قوي جدا وتقنيات متطورة جدا لتلافي الأضرار. الشيء اللي يأتي من الفضاء بطاقات عالية جدا، اثنين يأتي بشكل عشوائي ولا ندري في أي وقت. فإذا يجب أن نأخذ الاحتياطات الكافية لتلافي التلف أو لتخفيف الأضرار للمستقبل. وإحنا نعرف الأقمار الصناعية الآن جميع فعالياتنا المرتبطة بالجو عن طريق الأقمار الصناعية، من بث، من اتصالات، من دراسة ظواهر، وهكذا بث تلفزيوني. فتأثير تأثير الظواهر، تأثير الطقس على الأجهزة راح يعرفنا الدكتور. حماية البيئية للأجهزة، كيفية تركيب الأجهزة، كيفية إدامة الأجهزة، ومن ثم كيفية تخفيف الأضرار. مرة ثانية شكرا جزيلا دكتور إلياس على وجودك معنا اليوم، وإن شاء الله الكل راح نستمتع بالمحاضرة الشيقة إن شاء الله. شكرا جزيلا.
شكرا دكتور محمد يوسف على هذا المقدمة ما شاء الله. فلا داعي أنا أعطي المحاضرة أعتقد. أولا أشكر يعني ودي أشكر مركز الشيخ إبراهيم بن محمد الخليفة ما شاء الله. فكان دكتور محمد قام بزيارة دورة ما شاء الله، فحقيقة يعني مركز جميل جدا exceptional، فريد من نوعه ما شاء الله، وهذه القاعة كذلك فريد من نوعه ما شاء الله. فمركز هام جدا لنمو العلم، هذا ما نحتاجه نحن العرب المسلمين. فإن شاء الله يعني تزدهر أمور، وحقيقة يعني مستقبل مزدهر وطويل إن شاء الله. كذلك أشكر زميلي الدكتور محمد يوسف على الاستضافة ما شاء الله، وعلى ترتيب هذه المحاضرة وكل شيء. عندما خبرني بأن هناك محاضرة كل أسبوع كل أسبوعين، هذا حقيقة عجيب جدا يعني. وعندما شفت كل هذه الصور ما شاء الله للمحاضرين هنا، فهذا حقيقة شيء واحد يفتخر به. فجزاكم الله خير مرة ثانية إن شاء الله.
مرة ثانية شكرا جزيلا.
حياك الله. Usually when I speak, I am at the level of the people. Now I am high. I don't know why I am high. So doesn't mean that I took anything, but I am high. I would try to work around if possible, inshallah. When I saw the ad of my talk, I was surprised to see some French sentence. I said, maybe I have to give this lecture in French. I am from Algeria. Ça serait très bien pour moi. Mais pour tout le monde, ça sera, je ne sais pas quoi. In French? Oui, oui, in French? Okay. Space weather mitigation. Maybe some of you have no idea what does space weather mean. الطقس الفضائي. I'd like to speak Arabic and English, if possible. For sure, every one of us, he would like to go, let's say, for a picnic. He will check what first? He will check what will be the weather tomorrow. Will be sunny, rainy, or whatever, so you need to check the weather. شوف الطقس كيف يكون الطقس غدا. هل فيه عاصفة رملية، في أمطار نحن نحب الأمطار ما شاء الله، لكن ليس عندما نخرج في نزهة يعني. ف space weather is same, more or less. So I will try in this talk, hopefully to be around 15 minutes if possible, to cover these subjects. First of all, what is space weather? ما هو الطقس الفضائي? The main culprit, which object that is so important for us is responsible for that? The space weather effects, that we see them every day. Space weather awareness, globalization, because space weather is not like something located only to one single country or maybe one single continent. It covers the whole planet Earth. So it is a global problem. Space weather science, yes. In some universities in the world, they give space weather courses. They even have MSCs in space weather, yes, because it is something that is very, very important now. Space weather mitigation, PTL. What does PTL mean? I gave one day the same lecture, and I forgot what is PTL. We'll see it, inshallah. SAS, space weather program. What is SAS? As Professor Muhammad said, so I am the previous director for the Space Science Department at the Sharjah Academy for Astronomy, Space and Technology. A space science department that I did create from scratch. 7 research labs, 35 researchers. I am no more astronaut with that, alhamdulillah. I will talk about something called SolSat. 2 of my ideas, 2 satellite, 6U CubeSat, SolSat GNSS, and at the end I will give some kind of conclusion. If you'd like to understand the distribution of slides, this is a histogram showing how many slides per each subject. So, what is space weather? Well, it is something that is related to the sun. As Earth climate is related to the sun, space weather is also related to the sun. It's very, very important. This shiny star that we are so merciful that it is around us, or we are around it, is also the main responsible for all what we see in terms of space weather effects. It has different strength. It all depends upon how active is the sun. And also, it is mainly governed by something that we astronomers call the 11-year solar cycle. The 11-year solar cycle is a cycle that we count the number of sunspots every day, every week, every month, every year, and so on, and we plot them. So there is some kind of cycle. So what you see here as a figure to the right is what we call the number of sunspots. The number of sunspots you can see here on this y-axis against time. This is like a record from 1985 to 2020, and as you can see, the number goes up, then goes down, goes up, it goes down. On average, it is between 7 to 14 years to 15 years, and on average, we see it is an 11-year cycle. So what does it go up, and what does it go down? It has to do with the sun. So we measure, we observe. So we have maximum and we have also minimum. It does not mean that when the number of sunspots is high, that the weather on Earth weather is going to change. No. So I'm going to talk about it, what will be the consequences if we have a high number of sunspots. Sunspot is what we call in Arabic البقع الشمسية. عدد يتغير. في بعض الأحيان نرى عدد كبير وفي بعض نرى عدد يعني نوعا ما قليل يعني. So as I said, the main culprit is the sun. So our star, for sure some of you may have taken an astronomy course with Dr. Walid, mashallah, my old friend, and the sun is one star that we are so merciful to it. It is what you call the G25. What does G25? So we divide stars into 7 types, 7 spectral types. O, B, A, F, G. Oh boy, a fine girl, kiss me. No, we don't say that. And a 5 means that it is a main sequence that it is living its normal life. نجم يسمى بالعربي نجم التتابع الرئيسي. ايش النجوم التتابع الرئيسي؟ نجوم لديها وظيفة واحدة الآن فقط، وهي اندماج الهيدروجين لتكوين الهيليوم. The first nuclear phase that a star has to start to be called a star. Otherwise, it cannot do that because we have so many also failed stars. It does rotate, and this is the cause of the sunspot. It does rotate differentially. Planet Earth, wherever you are, you go around, you make one full rotation in 24 hours. You are here in Bahrain, mashallah, you are in whatever country, you make 24 hours. On the sun, no. It all depends where you are. If you are at the level of the equator, you make one rotation in 25 days. You say 25 days is a long time? Oh, that's fine. You go up north, you go up south. It goes slower. So this is called the differential rotation, دوران تفاضلي. And because of this, and because of the sun magnetic field, these sunspots are created. I'm not going to teach you the sun today, but just to make sure that you understand that this is very, very, very important. And also its axis of rotation is inclined by 8 degrees. This is a good picture of the sun taken by SOHO. SOHO, for those people specialized in the sun, is very important. It has been running since 1995. Do you believe that? 1995? We are 2024, meaning it is almost 30 years, and it's still working. Doing what? Just observing the sun, mashallah. And this recent picture, as of November 19, I believe it was, I cannot read this number. Can I read it here? It doesn't matter. So, but it was yesterday. And look what we see on it, these black spots. sunspots. You see that these are tiny. No, no, no. These are very, 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 very big ones. Sometimes we see nothing. This is minimum. And sometimes we see a lot. On average, we see about 100. But look at these two numbers. I just found out that the highest number of sunspots was 25th of August, 1870, 528 or 3. I don't see very well, 8. And this is in 1957, 503. Do you believe that? So this sunspot can be a lot. This is an active region, AR29, whatever. So you see, this is the size of Jupiter. For those people who know astronomy, Jupiter is about, in size-wise, I don't give you the number in kilometers, it is about 11 times the diameter of Earth. So this is the size of Jupiter. And the Buqu' Shamsiyya, you may ask me, why are they dark? Usually a sunspot بقعة شمسية تحتوي على منطقتين منطقة الظل the what you call the umbra, the penumbra. Doesn't mean that there's something above it. No, 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 no. This is how the way. So why is it dark? Because if you put a thermometer here, it will reach 4,000 degrees. If you put a thermometer here, it will reach 6,000 because this sunspot, they lie on the photosphere. And the photosphere, as you know, الفوتوسفير وما يسمى بسطح الشمس الذي نراه. ليس بالعين المجردة. لا تحاول ترى العين الشمس بالعين المجردة. So you're going to become blind forever. For sure, you need to use a filter and so on. So there are 4,000. I'm sorry. There are 4,000, but they look dark because they lie on something brighter. I'm sorry. They lie on something brighter. So this is 4,000. If you take one black spot, put it itself in space, it will be as bright as the moon. It's very hot, 4,000 degrees. But because it lies on something hotter, it appears dark. So these sunspots are very, very important. And as you can see, the sun photosphere, this beautiful granulation. This is a very high resolution picture of the sun. Also, we have this beautiful graph that shows the number of sunspots. The number of sunspots as a function of time, and as you can see, we are now in 2024, so we are cycle 25. For those who don't know, usually we go, the sun activities, they go by cycle. Every cycle is about 11 years, so we are cycle 25, meaning that this we are counting since the time we started to measure sunspot. Okay, if you take 25 multiplied by 11, you get 300 something years. So this is how we measure. And also I forgot to tell how do we measure these numbers, the number of sunspots. It's very, very important to know that one because we have two classifications, one from the Americans and one from the Europeans. So they use different techniques, but they end up almost the same number, and I won't go into the details. You can, for sure, you can Google it and see what is. The sun is very active. Look at this beautiful solar prominence. Look here, we are just putting planet Earth to scale. It's very huge. Just imagine this piece of energy is moving toward planet Earth. Yes, we are protected. We have this beautiful magnetic field around us. It may protect us a little bit, but sometimes when the sun is very, very upset, we suffer, and this is part of the space weather effects. And you can see also here another beautiful picture of the sun with all of this bright active region and this very beautiful loop that may go maybe more than 200,000 kilometers into space. So this is a beautiful picture from Soho. This is a coronography. What is a coronography picture? So we hide the sun by a disk. So this is the size of the sun behind the disk. And you can see this, what you call the CMEs, coronal mass ejection. Why it is called coronal mass ejection? Because the outer atmosphere of the sun is called the corona. So it is best seen during this special type of, I can say, artificial eclipse. So the best way to see this beautiful corona CMEs and also the solar phase and so on is when you have a real total solar eclipse. When the moon comes and hides the sun, we can see the corona that does extend millions of kilometers. And it's a very hot, it is a very hot environment. Here, the temperature here outside here is about 1 to 3 million degrees. Do you believe that? The sun's surface is about 6,000 degrees. Inside the sun is about 50 million degrees for the sun to be called the star, to be able to fuse. But outside is 1 million degrees. Do you believe that? What is happening? Is physics wrong? No, physics is not wrong. So what is happening, and we would like also understand what is happening, but it is 1 million degrees. It is 1 million degrees, and if you dive inside, nothing will happen to you. Do you believe that? Nothing will happen to you. Safe and sound. For sure, you won't be killed by the corona, you will be killed by the heat of the photosphere. Why is it, why nothing will happen to you? Because it's like, for example, if you go to Saudi Arabia, I don't want to fall and I will go broken there to my wife. So when you go to Saudi Arabia to Abha is, during summertime, is cool, صح? You go to Sultan Oman, Salalah is cool. Why? Because it is high in altitude. The higher you go in altitude, the less particles you have to get that energy. So here the density is 1 million degrees. But the number of particles is only 1 particle per cc, so nothing will happen to you. You won't feel it. It is hot, but you won't feel it. So this is just part of physics. So look at this beautiful explosion. This is the side that is not facing Earth. Usually we classify these solar flares by different classifications. I won't go into details. So this is an M4, so we have an X class, and so on. So we measure, we observe this activity. So we do this observation, alhamdulillah. A cartoon showing our relation to the sun. The sun for sure has its own magnetic field, and Earth does. Not because of the sun, just because Earth rotates. And as you know, for those students, for anything to have a magnetic field, 2 conditions must be satisfied. First of all, that object, like planet Earth, must have a liquid hot core and must also rotate. 2 conditions. Because as it does rotate, those ions inside, they move, and whenever you have a charged particle moving, it does create a current. Whenever you have a current, you have an electric field, and whenever you have an electric field, you have a magnetic field. That's why we have a magnetic field. If Earth were to rotate very, very, very slow, like, for example, Venus, we'll be dead. Because our magnetic field will be so weak, and for sure, the sun's solar wind will be doing its usual business. So most of these highly charged particles, instead of being deflected by this Earth magnetic field, some of them will go in and will either touch the whole planet Earth, or we just only go from the poles. And when they reach the poles, you know, they create this beautiful aurora that we see in the northern part and also in the southern part. So this is just beautiful. So this highly charged particle, we understand a little bit what is happening here. We don't understand very well here. But we send this, as some of the solar physicists know, we send this solar Parker probe. And by the end of December, this solar probe Parker will be as close as 6.7 million kilometers from the sun. Do you believe that? يعني القمر الصناعي يصل إلى 6.7 مليون كيلومتر من الشمس. الشمس موجودة هناك 150 مليون. So this solar probe will be 6.7. Do you know how it is cooled? The same method that you use in your refrigerator, being cooled. For sure, it doesn't look directly at the sun, but it will take some measurement, because we'd like to know how these highly charged particles are being accelerated here, because once we know how they're being accelerated, we may know why that corona is 1 million degrees. Yes, we may know that. The space weather effects, and for sure some of you know these effects that did happen. The best known for people of my age is this one. The 1989, what happened to northern Canada. Or maybe this one, the Halloween storm, where we almost lost 30 satellites. But this one was the most powerful, the Garrickton effect in 1859. 1859, we didn't have our beautiful mobiles. We didn't have our powerful satellites. We had nothing. We had just that telegraph, that all the click, 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 whatever. And even with that click, 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 whatever, the whole world burned down. People saw the aurora. Usually the aurora, you see it above 60 north and above 60 south. But the aurora in 1859 was seen as far as Cuba. Do you believe that? South, 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 south. Because the aurora, these highly charged particles can only penetrate around the north and the south pole. But this was as Cuba, meaning that it was very powerful. So I believe you may have that this past summer, some people in the US were being able to see auroras at the level of Florida. Do you believe that? Why? Because the sun was also active. So these are some past events that did happen, like the one that I was mentioning here. This is in just this past summer. Just to give some specific about what happened to Canada in 1989, look at this transformer being burned. This was in New Jersey. And what is bad, I believe this is for the whole world. Now, whenever you have a power station, a station that does produce electricity, it doesn't work by itself. There's a grid. There's a grid. In Europe, you have thousands of power stations. They are under one system, one grid. Why? Because if one system goes down, the other will take over. But when space weather effect happens, this is bad for everyone, because it's like a build a castle with only cards. Everything will fall down. This is exactly what happened in 1989. So this happened in Canada, but New Jersey did pay the price. Look how much energy was shut down. 21 gigawatt of supply. So this northern part of Canada was in darkness for 9 hours. 6 million people didn't have it. And thanks to God, it was not real winter. It was not December or January. It is very, 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 very cold. So it does affect the whole system. Now, to get into deeply into the subject, so if something happens to the sun and we get affected, but we have a protective field, we have Earth magnetic field. So how does it get affected? How sensitive are our instruments to anything that happens inside the sun? And that inside the sun, when it does reach us, how does it affect the magnetic field? Well, just to give you some numbers here, we start to feel the space weather effect when there's a change in the magnetic field between 50,000 nanotesla to about a few nanotesla. Just to give you some numbers, magnetic field Tesla, okay, what does that number mean? Look at it here. If I take the sun, this is its magnetic field, 0.001. This is planet Earth, 000 whatever. This is planet, do you know this sign? Planet Venus, yes. About 0.015. This is, mashallah, this is planet Jupiter. Look how strong it is. This is those beautiful magnets that you put on your fridge to decorate your fridge. Look, 0.0 whatever. And by the way, just an advice to you, never use this magnet on your fridge, because your fridge has also its own magnetic field. It is because of you, because you're putting so much of your souvenirs here, mashallah. A sunspot, 0.4 strong. And if you go to those junkyards, so they use this big magnetic field. So a small change can affect you a lot, a small change. Usually, so what happened in Canada, look at it here. It was the fluctuation inside Earth magnetic field were around about 500 nanotesla per minute. And this did disturb those big generators. What happened in New York in 1921, it was about 5,000 nanotesla. So it is something small, but that something small does affect the power grid. Why? Because that power grid does generate a magnetic field, and you have some kind of induced current, and that induced current can be as strong as 1 million ampere. Yes, 1 million ampere, so it can burn anything on the ground. And if in the future we're going, mashallah, to have this beautiful clean energies, renewable energy like wind energy, tides energy, hydro, solar, so you have to think how you are going to transport that energy. You need to have some transmission lines. And those transmission lines today can also be affected. So that's why you need to think about these problems, and they do happen. So I won't want to go into all the details because there are so many things to say, but something is very important to talk, like Professor Muhammad said, satellites. Yes, satellites. So there are so many things going on in space, so we need to have some kind of protection because we communicate with each other. We have our mobiles, you communicate with satellites, you communicate with anyone elsewhere. So these systems get affected. I'll take some water. So these systems get affected. So here I'm listing some problems related to radio communication. So we have so many people using, like in the amateur, like you would like to build an industry. You have to do some emergency calls and so on. All of these are related to each other. So all of these, they do use high frequency radio communication. And why is it important? Because whenever you have this high activity of the sun, okay, so our atmosphere is going to be bombarded by these very high energetic particles. They can be protons. And these high energy protons are going to hit that atmosphere. Our atmosphere is going to expand, and as it does expand, for sure, the number density of particles is going to increase, and as is going to increase, so there will be some kind of radio blackout. So this is a problem. We have also, in terms of satellite communication, this satellite, when it does send its signal, it has to cross Earth atmosphere. So either uplink or downlink, so something is going to affect that signal. So we have so many satellites. We have this what you call this geostationary. We have this Monia satellite. You may ask me what is Monia. Monia is a Russian word that means lightning. So Russia, during the 60s, 70s, they sent hundreds of these satellites. These are very, very highly optical, so they cross around the poles and so on. And also today we have this low Earth LEO satellite like the CubeSat and so on and so on. So all of these get affected because they are within our own atmosphere. I won't go into details. This one, so this also satellite drag, because when our atmosphere goes up, okay, it does extend. Some satellite, they will feel this drag because they are put at, let's say, 500, 600, 700 kilometers because the atmosphere there is low. But if it is high, so there will be some kind of drag, and after year, so they may fall down. And the best example that happened about 2 years ago, you may have heard about it. let me skip this slide right here. This is what happened. What happened to SpaceX? It lost 40 satellites. When the rocket went up, the sun also went up in activities. Our atmosphere got beefed up. This satellite, they were supposed to be about 240, 250 kilometers for a couple of days or maybe a week, and they will use their own thruster to go to high altitude. So they didn't have time to go to high altitude because they were within a very high density atmosphere. So that's why SpaceX did lose this 40 satellite, and the cost was about $100 million. So this is real. So it does happen to us if we are not careful enough. GPS systems. Who does not have a mobile today? Who does not have a car with a GPS system? Usually when everything is calm, so your GPS system will take you to about maybe a couple of meters to your location. And if sometimes the sun is very active, so this signal, as is going to cross the Earth's atmosphere, is going to be disturbed, and you get the wrong location maybe by 10, maybe by 20, maybe by 50 meters. We have 10, 20, 50 meters for us is fine. That's fine. I can see that building over there. But how about if you are sending a rocket and it will miss its target by 10 meters? That's why, so this is a real problem, so GPS. So usually we use this dual GPS where you can get up to about a centimeter. And sometimes yes, sometimes yes. Military application, you can go up to about millimeter. Impact on climate. We receive that light from the sun. When I say light, in all of its flavor, from the shortest wavelength, okay, gamma ray X-rays, to the longest one. Thanks to God, we have our own atmosphere. That gamma, that X-ray radiation is absorbed at about 90 kilometers. Why? Because we have nitrogen, we have oxygen there. UV is also absorbed. You know why. We have that beautiful ozone layer. Infrared is absorbed. UV is absorbed by about 50 to 60 kilometers. Infrared is absorbed, even though infrared is not harmful, 9 to 10 kilometers, it's absorbed because we have water vapor there, it is absorbed. Radio it goes through because it has a long wavelength. So when the sun is active, this light that we receive in all of its flavor get affected. Optical light doesn't get affected a lot, 0.1%. UV it does. Infrared, it is almost stable. So that's why what we measure from the sun, and this is what I said earlier, that the sun activity does not affect Earth climate. I say Earth climate, not space weather, because look, we usually measure the total energy we received from the sun by this number called this total solar irradiance, TSI. For those people who do architecture, they must know this number because they would like to build their houses, whatever. Look at the number. How does it change? Solar minimum 1365, solar max 1360. It is only nothing. So these sun activities, this number of sunspots that we see do not cause the seasons, as you know. The main cause of the season is how high, how low is the sun with respect to your horizon. How high, how low? It is because Earth planet is inclined by a spatial angle of 23.5. For those people who study astronomy, the ecliptic directional Buruj. So no direct effect of the sun activities from minimum to maximum on Earth weather, okay, directly. Now, space weather effect. So we have seen that space weather can affect so many things, so let me skip this line. I don't like to read. I'd like to see an image. This is the sun. And this is all what it does bad to us. So let me put here, let me take my beautiful eyeglasses to read a little bit, if I can read. So the sun does so many bad things to all of this. Let me put my glasses back. So for everyone, for the astronaut, because usually whenever we send someone, like we have right now, we have the ISS, we have some astronauts there, they are protected by Earth magnetic field. But for sure, if we send someone to the moon, there's another story. The moon has a very, 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 very weak magnetic field. How if a solar storm happens, how are we going to protect our space astronaut? Even your capsule doesn't protect you. You have to say that to those pilots that do fly around Earth North Pole. That's why every couple of weeks they do a check, a medical checkup, because they pass through what we have most of the highly charged particles. So if you have a rig here on the sea, so if you are digging something for oil, so you may miss by a couple of centimeters, because your GPS system is not working right. Your satellite may drag, as I said, as also say those pilot, those GPS signals. So everything, those power line, PTL, power transmission line, they do get affected. So all of this is being affected by just one single object, the sun, when it is very, very active. So it is global, as you can see it. It does affect everyone. It does affect every one of us. You cannot say it doesn't concern me. No, it does concern, because we live under one world. What does affect someone does affect the other one, especially when you talk about power. You lose power, especially when your favorite fuel station is down, does not distribute fuel because there is no power. Or maybe your fridge will run out of electricity. Or maybe you don't have water because that power plant, that water plant cannot move water to you. Or maybe sanitation gets very smelly. Or maybe communication, and we live by mobile. Let's say you go home, there's no internet, you feel lost. And if you have kids, they will say, Father, what did you do to the internet? Did you shut it off? Did you pay the bill? Medical health, yes. Especially in the West, I don't know, here around, they use a lot of these pagers and get their communication through satellites. How about if it is down? Finance, the stock market, it doesn't work, and also transport. Everything in the city, you have a red light and so on. You have so many things that does use electricity. So how if this is affected by the sun? So this is chaos, and we don't like chaos. So the space weather science, if you'd like to build the space weather course, it does deal with all of this. First of all, you need to understand what is the solar wind. What is a magnetic storm? Well, what is a magnetic storm is when we have that very, very highly charged particles coming to our own atmosphere, okay, especially those protons. They will create, because they are moving, they will create a magnetic field, and that magnetic field is going to disturb Earth magnetic field, and that power grid is going to get affected. So we need to understand that. Solar radiation storms, like these very energetic particles, solar radio burst, yes? What do you mean by solar radio burst? So it is so intense in the radio domain that you'll be like in a blackout. No communication. Galactic cosmic rays, well, usually most of the galactic cosmic rays, they come from this beautiful supernova, galaxies and so from space, and they do reach us. So we are more or less protected by Earth magnetic field, but sometimes we are not. What is good about space weather effect and this galactic cosmic rays that when the sun is very active, believe it or not, when the sun is very active, the density of these cosmic rays goes down inside Earth. This is good for us. Why? Because our own atmosphere is going to beef up, and there will be more protection against these highly charged particles. So most of them will be some kind of deflected. High-speed solar winds and solar. So all of this is part of a core that you can build to understand the physics of space weather. Again, the same slide almost. So our star, the sun, is going to generate these very highly charged particles that will get interact with the magnetic field, and most of this solar is going to be deflected, but some of it can get inside Earth North and South Pole, and sometimes when it is very, very active, so this Earth magnetic field is going to be squeezed, and we're going to pay the consequences as we did. Thanks to God, so this space weather problem has been around for more than about 40 years. That's why there is a constant monitoring by those people who care, especially those space operators. So there's a special site that you can get. This is for yesterday, November 19. And as you can see, we are all green in terms of radio burst. We are all green in terms of solar radio burst. And we are all green in terms of geomagnetic storm. Alhamdulillah, we are green, so there is nothing. But sometimes you will see change. You will see either yellow or either red, that something is going to happen very, very. So there's a continuous observation of the space weather problem. So what can we do? Space weather mitigation. It depends who you are. For those people who do build satellites, they have been using since decades space component that can sustain any space weather effects. When you build a satellite, what you put as component is space proven, especially if it goes into geostationary. So we know that, so it has been used. Augmentation network. What do you mean by that? So you don't rely on only one satellite. You may have a constellation of satellites to rely on. So if one goes down, so the other one will take care. Special device, especially if you are responsible for a power station, your generator must be protected. Today they're using these special capacitors, and sometimes they're using extra magnetic field to protect this generator. Triple redundant circuit, especially if you have a spacecraft. So usually every system is doubled. High quality receivers, people are trying to do that. So whenever you have a satellite, so your GPS system is also space proven. And also high pressure local clocks to enable time sensitive services. Why? Because sometimes those clocks, because of the space weather, get a little bit affected, and they won't give you the right time. When I say the right time, it's not by the second. No, I mean by the microsecond. This is very important. So what can we do also? So we need to have some kind of space weather culture. So our people need to know that space weather is real. It does affect things, and we would like to follow on these things. That's why we need to more or less to have special education courses about space weather. Those companies that are affected must know about it, and they must also find a solution to their businesses. So this is all about. I talked about transformer design and also operational procedures. So what to do if something is going to happen. So we need to prepare people, especially those space operators, especially those power station operators, how to deal with these exceptional conditions and so on. This is the meaning of PLT, power line transmission, that I talk about it. Grid resilience, so because all the grids are related to each other, so we need to have some kind of solution to that. education and awareness. So we need to train people on this space weather effect. Collaboration, it is not a problem for one single country, it is a problem for everyone. So that's why we need to have a global collaboration and also do a lot of research. That's why we are sending a lot of satellites into space to study that. Just to talk about what I did when I was at the Sharjah Academy for Astronomy, Space Science and Technology. So I was able to build a space weather program that is related on 3 systems. First of all, on the optical observatory, where we monitor, we observe sunspot on a daily basis as long as it is clear. I was also to build a a decametric radio telescope to measure these solar radio bursts on a daily basis, and also to measure the solar radio bursts that so many times, this is type 2, type 3, and so on. So this is on a daily basis. And also we have this GNSS station. I know that there is a GNSS station here in Bahrain used by the US Army. So we have one in Sharjah. And this receives signal from all GPS satellites, the Chinese, the Americans, the Europeans, everything. And also with this ionoson that does send a signal between 2 to about 15 megahertz into space. The signal gets reflected, and we observe it here. And this will tell us the status of the ionosphere, how it is doing, how it is affected by this space weather effect. So we do this on a 24-hour basis. I had also in mind these 2 satellites, the 6U, a SolSat, a space weather satellite, and also a GNSS satellite, Global Navigational Space System. So this is 2 6U satellites, so to be able to be sent at LE or low Earth orbit to be able to understand what is happening here inside and how can we model. So this is hopefully will be done in the near future. Also this GNSS satellite, just to be part of this business of space weather and so on. This is my conclusion. You heard a lot about it, and thank you, Bahrain.